Greetings, fellow mathematicians. Let's talk about the pedagogy of questioning. Most of us were taught maths through telling. We were told how to do something, and then if we could do it, it was deemed we understood. If we couldn't do it, it was deemed that we didn't understand, but we were simply told how to do it again. Once we could do it, we were then told to practice it until we could do it independently. The learning theory was that if we were told how to do something and then we did it often enough, understanding would follow. The problem was that in many cases, understanding never followed. If understanding did follow, we never really knew whether it was important understanding, where this understanding fitted in with other concepts in maths, or whether it was a misunderstanding, a misconception. We now know that learning maths this way is not effective. Maths is not skill-based. Maths is conceptually based. This means that understanding of one concept is necessary to develop deep understanding of following concepts and of related concepts. Think about this. If we tell children about maths, at the end of the lesson, all we know is what we understand, what we know. If we ask children questions about maths, at the end of the lesson, we know what they know. We know what they understand. I've had teachers who say to me, I taught the children this in maths, but the next day they didn't understand it again. They had forgotten it. I'm sure that the teacher taught the maths through telling, which means that the children had to try to remember. Teaching maths through questioning means that children develop deep understanding. They construct new understandings. This means that they are constructing new neural pathways in their brain which are much longer lasting than simply trying to create a memory. So children need to develop deep understanding of mathematical concepts and the relationships between concepts and not simply do maths. Using questioning to teach maths allows us and the child to correct misunderstandings, to build on incomplete understandings, and allows every child to learn from their leading edge. So who asks the questions? The teacher asks the questions, the child asks the questions, and the children answer the questions. I make it a point when I'm in classrooms to never answer my own question or to tell the children about maths, and to never answer a child's question. If I have to answer a child's question, or if I have to tell something about maths, it means that no child is ready to learn it. This also takes the pressure off you as the teacher, because when you're asking questions, you don't have to have any preconceived answers in your mind. You're not looking for one correct response, you're looking to see what the child understands. As Einstein says, lots of times when we ask questions, we're asking questions to find out what the child does not know. Einstein says that we should be asking questions to find out what the child does know so that we can make sure that they're building on that knowledge. So how do we know what kind of questions to ask in the classroom? You can use the concept sequences to identify the children's current levels of understanding. The learning plans contain lots of examples of questions that you can ask to build on those levels of understandings. If you plan your questions to start at the lowest level of understanding and to build just past the highest level of understanding, every child will remain engaged. This is only a quick 10-minute part of the lesson, and the child is still making links to further learning as you're going through the same concept at different levels. Having children continue to question and answer questions throughout the lesson will develop deep understanding, will develop mathematical meta-language, and also an increased capacity to explain their deep understandings. As Rick Garlikoff says, if we can get the right questions in the right order, and the learning plans are there to help you with that, then we can engage all children across the intellectual spectrum in our classrooms.